afternoon, good evening, or good morning, depending on where you are today. I've been leading a smart utility project centered around Monum platform this last year or so in Burlington, North Carolina. And I'm really excited to be here today to share what we've learned and how we're helping to shape the future of smart utilities in the U.S. Here's our agenda for today, and it does look like a lot, but we'll start with a brief introduction of my background and of Core & Main, the company that I work for. Then we'll get into the Smart Utility Pilot Project in Burlington. I'll provide a perspective about the city and to start with, and talk about why we chose Burlington for the pilot. We'll talk about the scope, the use cases we chose to implement, the solution architecture, and a little bit about the pilot timeline. I'll also address some challenges we've had along the way. Like any project, there's been some challenges with this. And then I'll wrap up sharing some initial outcomes, some planned next steps, and a few words on a concept that you may or may not be familiar with called Beyond the Meter. And I believe Monum will be instrumental at realizing the Beyond the Meter vision. More on that later. So as Christina mentioned, my name is Joe Badera, and I'm joining you today from Raleigh, North Carolina. I've been in the water industry for about 15 years and currently serve as a program manager on the National Smart Utility team at Core & Main. I focus on developing smart utility programs that can be implemented across North America. This includes evolving our capabilities around advanced monitoring with a range of industrial IoT devices, as well as advanced software technology. Before joining Core & Main, I held several roles in project and program management, including 7 years developing and managing a project management office at a meter installation and services company, as well as 4 years as a professional services project manager at Sensus, a leading meter manufacturer in the US. And in a previous life, I was an application developer at IBM. So I have a bit of a strong technical background as well, which has proved beneficial in my career. Now, a little bit more about Core & Main. So Core & Main is a leading distributor of water, wastewater, storm drainage, and fire protection products, along with the associated services, and it supports municipalities, utilities, and contractor access across North America. Core & Main has a national presence with over 370 brick and mortar branch offices, about 5,500 employees, of which 200 are dedicated to the metering technology and the Core Plus initiative. More on Core Plus in just a few moments. Core & Main's been in business for over 100 years and is comprised of over 80 legacy companies. And as you can see, we have quite a large customer base in North America. Although the water industry is a primary focus for Core & Main, we're also active in the electric and gas industries as well. So advancing reliable infrastructure. Core & Main is focused on the infrastructure that keep communities running every single day. Whether it's water, wastewater, storm systems, Core & Main is committed to helping build and maintain systems that are safe, resilient, and built to last. And we do a lot, from the basics like ductile iron and PVC piping, valves and fittings, high-density polyethylene piping, all the way to advanced solutions like smart metering and water management technologies. Simply put, our goal is to help our customers run more efficiently, plan proactively, and take steps toward becoming smarter utilities. So what's Core Plus? So it's an initiative of Core & Main, and it has 4 components: smart metering, projects and services, software solutions, and advanced monitoring. Core Plus has one clear goal: help utilities tackle the real-world challenges they face. And Jorge went through a few of these in his presentation a few minutes ago. Aging infrastructure, water loss, expertise attrition, and operational inefficiencies. And Core & Main doesn't approach these challenges with a one-size-fits-all solution or mindset. Instead, we work closely with our customers to implement customized solutions to address their specific challenges. So Core & Main is a solution provider, and we've partnered with top hardware, software, and services companies, bringing together all of the moving parts into an integrated end-to-end solutions. And a key piece of that ecosystem is Monum. Core & Main is proud to be the North America reseller for the Monum software utility platform across the water industry. As you may have gathered from Jorge's segment, Monum is a transformational software platform that will help utilities modernize operations and move toward a smarter, more connected future. So here are two key components of Core Plus that I'm going to focus on today, and that's advanced monitoring and software solutions. So utilities are expanding their use of AMI in industrial IoT devices every day, like many of you likely know. With today's sensor technology, utilities can now measure pressure, level, wastewater flow, water quality, influent and effluent composition, air quality, resource composition, capacity, and pretty much anything else across the end-to-end water cycle. The list is almost endless. Also to note is the amount of data available that the utility has to deal with, and that data is growing exponentially. What was once cutting edge is now pretty much standard. Pervasive monitoring is becoming the norm rather than the exception. Collecting data isn't truly enough. How the data is used is what really creates value, and that's what Monum is all about. Transforming raw data into actionable insights for the utility. Monum, Monum integrates a wide range of data sources into a unified environment. Operational technology data like SCADA, industrial IoT devices, and AMI, along with information technology data from applications that the utilities use, such as GIS, CIS, ERP, and asset management systems. From this wide array of data, Monum applies machine learning and artificial intelligence algorithms to uncover trends, run predictive analytics, detect anomalies, and drive smart, proactive asset maintenance. These tools enable data-driven decision-making and can automate workflows as well. This technology allows utilities to shift from a reactive to a strategic, proactive operation. Given the challenges facing most utilities today, combining advanced monitoring with its associated data and the Monum Smart Utility software platform isn't just a solution, it's really a perfect fit. So we needed to identify a utility where we could pilot the integration of operational data with advanced smart utility capabilities of Monum. I had previously served as project manager for the Burlington smart metering deployment, so I was already familiar with their team, their infrastructure, and many of the challenges that they face. As an added advantage was the city's location, just a short 45-minute drive from my office. This would make collaboration and on-site work much more efficient. The city of Burlington is evolving into a bedroom community for Raleigh, which is the capital of North Carolina. And with its affordable and high quality of life, growing population, Burlington is already seeing the pressures and opportunities that come with rapid development. The city oversees water production, water distribution, wastewater collection, and wastewater treatment for its 62,000 residents and businesses, as well as some neighboring communities, making it an ideal candidate to explore real-world use cases for advanced monitoring and a data-driven smart utility software approach. But before jumping into a pilot, we started by engaging with the city to better understand their current challenges and to explore how targeted hardware and software technology solutions might help address them. As we held these discussions with the city, we generated a wish list how the city could utilize the new technology. Their priorities centered around shifting from a reactive to a more proactive approach, and also building on their recent LoRaWAN and AMI investments. They were looking for tools to help them anticipate problems, not just respond to them. early detection of water quality issues to predicting pipe breaks, spotting pressure anomalies, identifying wastewater collection system risks like I&I and blockages related to fog. It was about using the data and analytics to get ahead of the problem before they became emergencies. Then we explored these priorities, potential scope, and use cases with Monum, and we were very quickly aligned. Jorge showed a similar picture of our pilot scope. This is what we implemented for Burlington, and we intentionally designed the scope to touch many parts of the utility operation. The concept was to demonstrate how a fully integrated, data-driven approach could deliver real operational value across the board. We included predictive pipe maintenance to help reduce downtime and extend equipment life, and a variety of other industrial IoT devices to monitor various critical elements in the system, such as water pressure, water quality, pump vibrations, sewer flows, and manhole levels. We also included data from the city's existing AMI network, which allowed us to look at usage metrics and trends, detect various anomalies, and forecast future consumption. The pilot was structured to show how advanced monitoring and an advanced smart utility software platform can shift operations from reactive to proactive and create data-driven insights across the entire water cycle. Here are the 7 use cases we focused on during the pilot to demonstrate how the solution with Monum could drive operational improvements across the city's water and wastewater systems. For source water quality monitoring, we implemented a multi-parameter water quality sonde at one of the city's 3 water reservoirs to detect changes before the water reached the treatment plant. This would enable early intervention and reduce treatment cost and potential risk to public health. Predictive pump failure analysis utilized pump vibration sensors at a critical pump station to predict pump issues before a failure occurred, helping to reduce unplanned downtime and avoid emergency repairs. Monum would also provide smart predictive maintenance steps when needed. Distribution system pressure monitoring utilized real-time pressure sensors in a small portion of the water distribution network to alert city staff of leaks, bursts, or valve issues, and that allowed city crews to respond faster and reduce water loss and customer service interruptions. I&I monitoring utilized sewer flow meters, level sensors, and rain gauges to help pinpoint areas with unusual flows during and after weather events, helping to identify I&I sources and reduce unnecessary treatment of stormwater. SSO and fog blockage monitoring utilized manhole level sensors in strategic locations in the city to alert staff to rising levels or flow disruptions. These are often caused by fats, oils, and grease, the fog that I referred to, or potentially illegal dumping. This can identify compliance issues and also alert the city staff when proactive cleaning is needed to prevent an overflow in the system. Consumption analysis and anomaly detection utilize the existing AMI meter data to report on consumption metrics and identify abnormal usage patterns, such as continuous flow or sudden spikes in usage, which may signal leaks or theft or faulty meters, in fact. Monum's comparison of consumption patterns to other similar users identify what's called unsupervised anomalies. And finally, predictive pipe break analysis analyzed historical pipe break data from the city, asset material and age, and other parameters to estimate where pipe failures were most likely to occur, prioritizing maintenance and replacement more effectively. Based on the selected use cases and the industrial IoT devices we implemented, a solution architecture was developed to define the required data integrations. And the pilot included 2 primary categories of data. First, industrial IoT data from approximately 28,000 AMI water meters, and as well as the field sensor data needed to be integrated into Monum. Meter data was accessed through APIs to the water meter head-end system, which I believe Jorge referred to as the Neptune 360 system for the city. And as far as the industrial IoT sensor data, that was hosted on manufacturers' equipment portals. So Monum developed APIs to retrieve that data as well. Monum also needed to build one-time flat file integrations related to some of the information technology data utilized in the pilot. These included historical pipe break records, GIS shape files, parcel data, and meter and account data from their CIS system. Future integrations will incorporate data from the city's SCADA system that will further enrich real-time monitoring and control capabilities. Earlier in the webinar, Jorge provided a detailed overview of the Monum architecture, describing the components illustrated in the graphic displayed now. These elements demonstrate the robust capabilities and functionality that the Monum platform delivers. A very quick overview of the pilot timeline includes some key milestones, such as the initial proposal meeting with the city, solution design and planning, integration and platform configuration, equipment installation, testing, training, and currently ongoing platform use. The pilot took a little bit longer than anticipated to launch, and it was about a year, in fact, but that was due to discovery and planning sessions, coordinating multiple contractual agreements, pilot budgeting, and the IoT equipment acquisition as well. So the city's been actively using the platform for about 7 months now, and we're currently targeting to wrap up the pilot later this year in September. So like any technology project, this pilot has had its share of challenges, which generally fall into 3 categories. The first is data acquisition. We encountered some issues with missing or poorly formatted historical pipe break data. And in some cases, key asset attributes like pipe installation year or the material of the pipe were actually missing. So these data gaps impacted the accuracy and the overall value of the predicted pipe break analysis. And the city was a little bit hesitant to engage in another integration project related to their CIS or their utility billing system at the time of the pilot. So meter and account data that was provided at the beginning of the pilot became outdated over time. Second set of challenges arose during equipment installation. Some of the industrial IoT devices experienced either data sensing or data communication failures, or a combination of both. The resulting lack of reliable, timely data early on in the pilot made building confidence in the system a little bit challenging. The third set of challenges were around deployment. Technical issues during the first training session, along with a language barrier, hampered the city staff's initial Monum training sessions. This significantly impacted how well the solution was initially understood and adopted. While we've seen strong support and buy-in from leadership at the city, overall platform adoption has been slower than expected. The enthusiasm at the management level hasn't fully trickled down to the day-to-day users, who were the platform's primary target audience for the pilot. While the pilot has had its share of challenges, it's also delivered several meaningful and encouraging outcomes. Among the most impactful, identifying some potential mechanical issues with pumps, along with recommended corrective actions, some real-time water quality insights made possible through Monum's advanced analytics and data correlations that were previously very difficult, if not impossible, to achieve, and the detection of likely I&I sources within the system. Additionally, the platform helped validate suspected illegal dumping into the wastewater collection system and flagged unsupervised anomalies in water consumption patterns. These anomalies would not have been recognized had it not been for Monum. A recent and very encouraging sign came from the city's water resources director, who shared that he sees the Monum platform as very valuable, especially in pump vibration analysis and distribution pressure monitoring. So what's next? Once the pilot wraps up later this year, next steps will include deploying additional industrial IoT devices. During the pilot, we installed a pretty limited number of each type of device to validate overall capabilities. We installed about 20 IoT devices in total, but in the next phase, we anticipate expanding the deployment, particularly with more water quality and pressure sensors to increase coverage and system effectiveness. Integration with the city's SCADA and CAS or utility billing system will also be a key focus. These connections will enhance data currency and provide a deeper, more comprehensive visualization of what's happening across both the distribution and collection systems. Monum also has a very strong roadmap for future enhancements, and we're excited to support implementing new features and functions as they become available. And lastly, we'll continue supporting and encouraging user adoption at the city, doing everything we can as an external partner to help the city fully realize the value of this smart utility platform. So, at long last, I believe, a breakthrough. I propose that Monum is the future-ready solution the water industry has been searching for. For the past 10 or more years, industry leaders have championed a concept called beyond the meter. It's really a vision centered around AMI laying the foundation for future technology and innovation and long-term transformation. That vision always aimed at something bit greater. I believe Monum actively drives that transformation promise. It's more than just a software platform. It equips the water industry to modernize through practical, data-driven advanced technology. I'm genuinely excited to be part of this journey and to help lead that change alongside Monum. I'd like to thank everyone for your attention, and I'll turn things back over to Christina.